Let's start. Our first question, part A, states that the table below gives information about particles. Complete the table. The first line has been done for you. So here we can see that there are four different types of particles: particle A, B, C, and D. For particle A, number of protons is given, which is 12. Number of electrons is 10. Electronic configuration is 2, 8, and the charge on particle is 2 plus. Now we already know that we have that protons have a positive charge and the electrons have a negative charge. And you can see here the charge on particle is 2 plus. Now what does this 2 plus means? 2 plus means we have two more protons than the electrons. And here you can see there's a variation between the protons and electrons, and we have two more protons than the electrons. And what does the electronic configuration means? Electronic configuration means the arrangement of electrons in or the arrangement of electrons in the shells of an atom. Now here you can see number of electrons is 10. In total we have 10 electrons, and electronic configuration is 2, 8. Why it is 2, 8? 2, 8 because in first shell an atom can hold only up to 2 electrons, and in the second shell and the rest of the shells it can hold up to 8 electrons. So you can see 2, 8, 2 plus 8 is 10. Now for particle B, we have not been given the number of protons, we need to find it. The number of electrons is given as 18, and electronic configuration is given, which is 2, 8, 8, and the charge on particle is 1 minus. Now we have the charge, we have the number of electrons, we have electronic configuration, and we need to find the number of protons. What does this charge 1 minus means? 1 minus means that we have one electron more than the proton. This means the proton we have one proton less than the number of electrons. So 18 minus 1 will be the number of protons, which is 17. Well, we're just typing here. Our answer is 17 protons. So just 17 protons. Now for particle C, we have been given the number of protons. We have not been given the number of electrons. We need to find it. Electronic configuration is given, and charge on particle is given. Now to find the number of electrons, you can see the charge on particle states that it has a charge of 0. What does this mean? This means that we have equal number of positive charges and equal number of negative charges. This means equal number of protons and equal number of electrons. So if we have 18 protons, this means we also have 18 electrons. Now for particle D, we have a number of protons equals 8, number of electrons is 10, and we need to find the electronic configuration and the charge on particle. To find the electronic configuration, as I said you, for particle A, we need to check how many electrons are there in total, and here you can see that we have 10 electrons in total. So arrangement of electrons explains that the first shell of an atom can hold up to 2 electrons, and the second shell can hold up to 8 electrons. So this means our arrangement will be 2, 8. You can also add them, so you will get 2, so you'll get 10. So 2 plus 8 is 10. So our electronic configuration will be 2, 8. Now to determine the charge on particle, we need to check which one is greater, the number of protons or the number of electrons for particle D. We can see here the number of electrons are greater in number than the number of protons. Firstly, we need to check by how much it is greater. So 10 minus 8, it is greater by 2. So here we will write 2. But you also need to determine the charge. How you will determine the charge? Now we know that electrons have a negative charge and then the protons have a positive charge. And electrons are greater in number, so the charge will be minus. Now, part B states that gallium is a group 3 element. Define the term element. So here they're asking us for the simple definition of an element. The simple definition of element is a substance made of atoms that all contain the same number of protons, meaning one type of atom, and cannot be split into anything simpler. This is the simple definition given by IGCSE. I'll just copy this, copy it, and I will just paste here. Add text. 1 minute, guys. So your answer will be a substance made of atoms that all contain the same number of protons, one type of atom, and cannot be split into anything simpler. You can also check with marking scheme if you are confused. Now let's move on to part C. The following are gallium atoms. So here we can see that these are the isotopes of the gallium atoms. Complete the following table. They have given us the both atoms and they have told us to find the number of protons, number of neutrons, and the number of electrons. So if you see this diagram, which I'm going to show you one minute, if you see this diagram, this is the figure which you need to refer. Now, X, what does X states? X states that this is the chemical symbol of an for element. For example, Li, lithium, or sodium, Na, potassium, K, like these elements. And mass number is referred to as the upper number. What does this state? This states the number of nucleons in a nucleus. What are the nucleons? Nucleons are the total number of protons and the neutrons inside the nucleus of an atom. And the lower number states that it's called the atomic number or the proton number. This states how many protons are there in the nucleus. So let's move on to the question. It states to find the number of protons for this atom. So we can see the upper number is the mass number and the lower number is the atomic number or the proton number. So 31, we can see here is the proton number. So we can just simply write here 31 protons. 31. Now, it is saying to find the number of neutrons. How will find the number of neutrons? So as I said before, mass number is the total number of protons and neutrons, and this is the proton number. So to find the number of neutrons, we need to subtract mass number from the proton number. This will be 69 minus 31. So let me just calculate. 69 minus 31 will give us 38 neutrons. 38 neutrons. Now to find the number of electrons, I would like to tell you that the number of protons is same as the number of electrons. So until unless it has a charge. If it does not have a charge, it will have equal number of protons and electrons. This means we have 31 protons here, so we will also have 31 electrons. Now for this atom, to find the number of protons, we need to refer to the proton number, and it is 31. So we'll write the number of protons as 31. Let me just write here 31 protons. Now to find the number of neutrons, you need to subtract mass number from proton number, which will be 71 minus 31. Let me calculate it. 71 minus 31 will give us 40. So in total, in total we have 40 neutrons. Number of electrons. Number of electrons is same as the number of protons until unless it has a charge. So we can see that it has 31 protons. So this will be equal to the number of electrons. So your answer for the number of electrons will be 31. I hope you're getting it. 31. Question number 2. Rubidium Rb is a chemical symbol for the rubidium. It is a group 1 element. It has similar physical and chemical properties to the other elements in group 1. Predict how many electrons there are in the outer shell of a rubidium atom. It's a 1 mark question, and you need to predict how many electrons there are in the outer shell of rubidium atom. So how will you find this? If you look this statement, this is given by IGCSE notes. I will tell you at the end of the video from which notes to which notes you need to refer, and you can just revise or learn from these notes. So if you check this statement, elements in the same group have the same number of electrons in the outer shell, which gives them similar chemical properties. For example, if an element is in group 1, it will have 1 electron in its outer shell. Group 2 will have 2 electrons in an outer shell. Group 3 will have 3 electrons, and so on. So if you check here, this question states that rubidium is a group 1 element. So this means we can say that it has only 1 electron in its outer shell, because the group number determines the number of electrons in the element's outer shell. So we can say 1. Now, predict one physical property of rubidium which is same as that of a transition element such as iron. So we need to predict a common property between these two, between rubidium and iron. So I have just noted down some properties of group 1 metals and transition elements. And from these properties, I have determined some common properties. One common property is they are both conductors, good conductors of heat and electricity. So I can just simply write here, 1 minute. I can write here. They are good conductors. They are good conductors of heat and electricity. So this one, I'll just make it up. This is the common property between these two. Now part C states that predict two physical properties of rubidium which are different to those of a transition element such as iron. So I need to predict two physical properties, good conductor of heat and electricity. I just raise this. They are, because it's asking about only rubidium, not for transition element iron. Now part C, predict two physical properties of rubidium which are different to those of a transition element such as iron. So how will I do that? I will go into the properties and I'll predict two physical properties. So I think I can take two different physical properties. So I can first take rubidium is soft and easy to cut. This is the first property. And I can write as rubidium has low melting point and have low density. So firstly, I can write here that rubidium is soft and easy to cut. Rubidium is soft and easy to cut. And the second property I can write as rubidium has low density and has low melting points. If you want to score full marks in this question, you need to write these 2 points. You can also refer to other properties, but I prefer writing this. So part D, when rubidium is added to cold water, a reaction occurs. You know what happens when rubidium is added to cold water? You will get rubidium hydroxide and hydrogen. Just two observations that would be made when rubidium is added to cold water. So actually, what happens? You can write here. So these are some observations that when the other elements are reacted with water. So you can see for rubidium, when rubidium is reacted with water, it explodes with sparks and rubidium hydroxide is produced. Okay, so observation what we can see, I'll prefer writing explodes with sparks. Or you can also write bubbles of hydrogen gases are produced, but that will score you only 1 mark. So here, if you write this point explodes with sparks, you can get 2 marks. You can score 2 marks easily. So for one for explosion and one for sparks. So I will write explodes with sparks. Okay. So let me just take it up. I'll write here explodes with sparks. Okay. Now part 2, what would be the color of the solution if methyl orange was added to it after the reaction? Now, as I told you before, when rubidium is reacted with water, it produces rubidium hydroxide and hydrogen. Now, rubidium hydroxide is in the solution, and we know that rubidium hydroxide is an alkali. So, when methyl orange is added to an alkali, it becomes yellow. Okay, there are only two variations. When it is an acidic medium, it is red in color. When it is an alkaline medium, it is yellow in color. Rubidium hydroxide is an alkali, so I'll write here the answer as yellow. Part 3 states that write a chemical equation for the reaction between rubidium and water. Remember, whenever they ask you for a chemical equation, don't just write the chemical equation, write a balanced chemical equation, because 1 mark you will score for writing the chemical equation and 1 mark is for balancing it. So I've already balanced it and written it. This is the equation. 2Rb plus 2H2O will produce 2RbOH plus H2. Okay, let me just, okay, I need to add the text to make it accurate for you guys. I'll just copy this, cut this, and let's write here my equation. Yeah, now it's perfect. Part 4. Put the group 1 elements cesium, lithium, potassium, rubidium, and sodium in their order of reactivity with water. Put the most reactive elements first. These are the group 1 elements, and I have stated the how to do this. So you can see it as a diagram. These are the group 1 metals list. They didn't ask for francium, so we'll delete francium, and we will check lithium, sodium, potassium, rubidium, cesium. So here you can see the statement. You need to learn the notes for the reactivity series. So what happens? You need to learn the group property, the trends. Okay, so what happens here? As we go down the group, the reactivity will increase as we go down the group. Okay, this means cesium is the most reactive metal, then rubidium, then potassium, then sodium, then lithium. So I can state it here. My first group 1 element will be cesium, cesium, no, cesium. Next one will be, if we see the reactivity series here, we have rubidium, then potassium. So I'll write here rubidium, then I have here potassium, I'll write here potassium. Then we have here as sodium. Then the least reactive metal is lithium. I'll mention here lithium. Fifth question. Suggest one safety measure that should be used when rubidium is added to cold water. We know what happens when rubidium is added to cold water. It explodes with sparks. It is a dangerous reaction, so there is a risk of eye injury. So you need to wear safety goggles. Okay, so I'll write here, wear safety goggles. Part E states that the phosphate ion has the formula PO4 3-. Deduce the formula of rubidium phosphate. They're asking to deduce the formula of rubidium phosphate. So I will tell you how to do this. If you refer to this, okay, I'll just so we know that Rb is in one group. You need to learn the valencies for each group. Okay, if you want me to explain you about the valencies, just comment down below so I can explain you in my further videos. So now, to deduce the formula of rubidium phosphate, we know that Rb is the chemical formula for rubidium, and it has a valency of 1 plus because it is in one group, first group. For phosphate ion, it's given PO4 3-. PO4 PO4 3-. Okay, now what we need to do to reduce the formula of this rubidium phosphate, we need to cross multiply the charges with their opposite charges. For example, if rubidium has 1 plus, this 1 will go to PO4 and this 3 will go to rubidium. But remember, ignore the signs. Okay, write only the number, not the sign. So how we'll write this? We need to use the formula of this We'll write Rb3. This 3 will come to rubidium. Rb3 and PO. This one will go to this one will go to PO4. So we'll write as it is, Rb3 PO4. Okay. Now we are done with the second question. Now it's time for third question. Carbon dioxide and silicon 4 oxide are oxides of group 4 elements. Complete the following table. Okay, they have now firstly they're asking for a formula. For silicon 4 oxide is SiO2, and for carbon dioxide it is very easy. So the formula for carbon dioxide is CO2. Melting point for carbon dioxide is -56 and silicon 4 oxide is 1,100. This is because carbon dioxide is simple molecular substance. It has weak intermolecular forces. Hence, it requires less energy to break, and silicon 4 oxide has a macromolecular structure, so it requires more energy to break the bonds. Physical state at 25 Celsius, carbon dioxide is a gas, and silicon 4 oxide is a solid because it has a high melting point, and so it needs more energy to break. That's why it has a physical state of solid. So we can write here solid. For conduction of electricity, carbon dioxide is a non-conductor because it's a covalent compound, and covalent compounds cannot conduct electricity as all electrons are involved in bonding, and so there are no free electrons available to move and carry the charge. Same for silicon 4 oxide. You can see these both are nonmetals, so we can say it's a covalent compound, and so it is also a non-conductor. Non-conductor. Now, in terms of structure, silicon 4 oxide has a macromolecular structure, and carbon dioxide has a simple molecular structure. Simple molecular structure is for carbon dioxide. Let me just align it properly. Yeah. Now, part B1. Name the type of bonds that exist between the atoms in silicon 4 oxide. As I told you before, when two nonmetals are combined together, it is a covalent bonding, and when a metal and non-metal is combined together, it's an ionic bonding. So here you can see silicon is non-metal and oxygen is also a non-metal. This means it's a covalent bond. I'll just write here covalent bonds. 2. Explain why silicon 4 oxide has a very high melting point. This is the question. Explain why silicon 4 oxide has a very high melting point. Why it has a very high melting point? Let me tell you. Okay, if you check this sentence, this is given by IGCSE. Make sure you stay till end of the video so I'll tell you the notes which you need to refer to score full marks in your exam. Okay, so here you can see the statement SiO2 silicon 4 oxide has lots of very strong covalent bonds, and there are no weak intermolecular forces, and thus you need more energy to break the bonds. So it has a very high melting point. Okay, this answer you need to write in your exam if you receive this question. So here I can write my answer. Oh, I think 1 minute. You just copy that. Just copy the statement. Copy. Add text. Sorry guys for time delay. You can forward the video so you can solve it quickly. I'll just make it short in size so you can see the answer properly. Okay, I think there's a problem with this, so I'll just make from here. Okay, so this is the answer you need to write in your exam. SiO2 has lots of very strong covalent bonds and no nuclear morphosis, so it has a very high melting point. Let me just make it a bit more perfect, aligned. Yeah, this is the worst thing why I hate writing in PDF files. In B part 3, explain in terms of attractive forces between particles why carbon dioxide has a very low melting point. So now if you see this substance for 3B part 3, you can see here that it's highlighted. This also, 1 minute guys, let me just highlight it. So you can see the properly. So simple covalent substances such as carbon dioxide and methane, these are the simple covalent substances. We call them simple covalent substances. They have very strong covalent bonds between the atoms in each molecule, but much weaker intermolecular forces. And when we heat them, they thus require very little energy to break. This is why they have very low melting points. So I will just copy this sentence. Um, I'll just copy from here. Okay, and into here. So I'll just write here why they have very low melting points. Your answer is here. They have very strong covalent bonds between atoms in each molecule, but much weaker intermolecular forces between individual molecules, and thus they require little energy break because so they have low melting points. Now, part 4. Explain in terms of particles why carbon dioxide is a non-conductor of electricity. Now we all know that carbon dioxide is a covalent compound, and covalent compounds cannot conduct electricity as all ions are involved in bonding, and so there are no free electrons available to move and carry the charge. This is the answer. This is a simple answer you can write. Here, it's a 1 mark question. 1 minute. Just add the text so it's clear for you. So this is our 4th part. Now, part C. Suggest a chemical equation for the reaction between sodium hydroxide solution and carbon dioxide. Remember, it's a chemical equation. Do not forget to balance the chemical equation. So here I have already balanced it, which is 2Na, sodium hydroxide plus carbon dioxide will produce sodium carbonate plus water. Okay, I have also mentioned the states, the physical states. So I will just write here the answer. Remember to balance the chemical equation, don't forget, otherwise you will lose 1 mark. So I have here, this is the answer. Moving on to D part. And D part involves some type of, you need to know some biology. Okay, so D1, name the type of chemical reaction in which carbon dioxide is produced from fossil fuels. Okay, so there are 2 types of chemical reactions. When it is complete combustion, when one is incomplete combustion. Incomplete combustion is when there is not sufficient oxygen to burn. So in incomplete combustion, carbon monoxide is produced, and in complete combustion, carbon dioxide is produced. So it's asking about carbon dioxide production. So we'll write here complete combustion. Mention here complete combustion. D2. In D2, we have named the chemical process in which green plants convert carbon dioxide into carbohydrate. It's simple, it's photosynthesis. Because when carbon dioxide take in carbon dioxide and water as the raw materials, and they produce glucose, which is a carbohydrate, and plus oxygen. So we can say this is a process, photosynthesis. It's called photosynthesis. 3. Name the chemical process in which living things produce carbon dioxide. So you know it happens in your cells also. Living cells respire and they produce carbon dioxide. Even plants do it. Mostly at night they do it. Cellular respiration takes place. So we can simply write here respiration. respiration. I think it's the end of third question. Now let's start with our fourth question. Hydrogen peroxide H2O2 decomposes into water and oxygen in the presence of catalyst manganese 4 oxide. The equation is given, which is balanced. 2H2O2 aqueous will produce 2H2O plus O2. Part A. What is meant by the term catalyst? Okay, so they're asking here for a simple definition of the term catalyst. According to IGCSE, simple definition of catalysts is here. 1 minute, guys. It's here. 4A. A catalyst is a substance that increases the rate of a reaction but is chemically unchanged at the end of the reaction. Is a 2 mark question. 1 mark for telling 1 mark for stating increases the rate of a reaction, and 1 mark for stating that it is chemically unchanged at the end of the reaction. This statement should be 1 minute, guys. I'll copy this statement. Okay, so your answer will be a catalyst is a substance that increases the rate of a reaction but is chemically unchanged at the end of the reaction. You need to state these both points, otherwise you will lose your marks. Part B. A student uses the rate of decomposition of hydrogen peroxide using the apparatus shown. They have given us the apparatus is a gas syringe, a conical flask is given, hydrogen peroxide, a capillary tube is given, and you have a catalyst, you have hydrogen peroxide, and a graph is also plotted with the volume of oxygen produced in centimeter cube and time in seconds. So part B1 states that when is the rate of reaction highest. So here you can see from your graph, if you see the graph here, you can deduce that the line where it is most steeper is the point where the reaction rate is higher. So you can see, as you can see here, at the start the gradient, the line is steeper, so we can say at the start the reaction rate is higher. So I'll write here the answer for this question. At start the reaction rate is higher. Or you could also be specific by telling them at which point, for example, at time t equals 0. You can write this answer. I prefer writing this answer. Part 2 states that suggest one method of increasing the rate of reaction using the same amounts of hydrogen peroxide and manganese 4 oxide. So if you are thorough with the topic chemical reactions, you might have learned about the factors that affect the rate of reaction. One of the factors is surface area. Surface area, if you increase the surface area, it will be exposed to more reactants, and so the rate of reaction will become faster. So here, as we can see, for example, if the reaction might here is with lumps of catalyst, so what we could do, we could instead use a powdered catalyst. So I'll write here, we can use a powdered catalyst to increase the surface area. Use a powdered catalyst. Part C 1. Calculate the number of moles of hydrogen peroxide used in this experiment. Here we require calculation. We need to calculate the number of the moles. So just increase this size. Okay, it's okay. Okay, you need to calculate the number of moles. How will you do it? Okay, the formula, if you see the question, if you read the question above, you can see the student uses 20 centimeter cube of 0.1 mole per decimeter cube of hydrogen peroxide. Now, here they have given us firstly we need to check what information they have given us about hydrogen peroxide. So they have given us the volume of the hydrogen peroxide, and they have given us the concentration of hydrogen peroxide. And we need to find an equation that involves both the concentration, moles, and volume. And I know one of the equations, that is number of moles equals concentration times volume. Number of moles will be concentration they have given as 0.2 if I'm not wrong. Let me just check, cross check. 0.1, 0.1 mole per decimeter cube, and you will multiply this with the volume. But make sure now they have given us the concentration is 0.1 mole per decimeter cubed, but the volume is given in centimeter cubed. We need to convert centimeter cube into decimeter cube. So what we'll do, we'll divide the volume by 1000 to convert the centimeter cube into decimeter cube. So the number of moles of hydrogen peroxide, number of moles will be, let me just calculate, 20 over 1000 times 0.1, which will be equal to 0.002. 0.002 moles of hydrogen peroxide. So I'll also write it here. So our answer will be 0.002 moles. Part 2. Use your answer to C1 and the equation to calculate the number of moles of oxygen produced in this reaction. Okay, they have told us to make use of the equation and to make use of the number of moles of oxygen from the part C. We need to make part C answer we need to use. So here what we need to do, we need to take the molar ratio for hydrogen peroxide. So hydrogen peroxide is to oxygen. We need to take the molar ratio. So what is the molar ratio? For hydrogen peroxide it is 2, and for oxygen it is 1. So 2 is to 1. Sorry, 2 is to 1. Okay. Now, what does 2 is to 1 means? We can see that answer for the moles of hydrogen peroxide was 0.02. So, to calculate, so if this is 2, so the 1, so if hydrogen peroxide is 2, oxygen will be half of the number of moles of hydrogen peroxide. So we can simply write here moles of oxygen equals 0.002 divided by 2. We'll get the answer as 0.001. So our answer for number of moles of oxygen will be 0.001. 0.001. Now we are heading to part 3. Part 3 states that calculate the volume at room temperature and pressure of oxygen produced. Okay, so we need to calculate the volume of oxygen this time. Let me just add the text so I can show you my working also. You can understand properly. Let's show you how I did it. I already solved it before, but to show you I need to just do that. So we have the equation volume of gas equals moles times 24. This is the equation we have. Okay, so what I will do, I'll just add text here. Now I'll calculate and write the equation. So my equation is volume equals moles times 24. You need to give your answer in decimeter cube. That's why you're multiplying with 24. If your answer was in centimeter cube, you will multiply the moles with 24,000. Okay, but it's in decimeter cube now. So we will say that volume of oxygen, we got the moles before, 0.001, 0.001 times 24. 24. Now it's calculated 0.001 times 24 will be 0.024. 0.024. Guys, 0.2, yeah, 0.01 divided by to multiply by 24. This will give us 0.024. So our answer will be volume equals 0.024 dm cube, decimeter cube. So let's write the answer here also, so you can clearly understand what I'm trying to explain. Make sure you practice these type of questions to get expert in these questions. So our answer is 0.024 decimeter cubed. Part 4. What would be effect on the volume of oxygen if the mass of the catalyst was increased? So answer for this question is what? There will be no change. Why? Because catalyst just lowers the activation energy. It does not have any effect on the rate of the reaction. So you need to write no change. No change. Simple answer. Deduce the volume of oxygen that would be produced if 20 centimeter cubed of 0.2 mole per decimeter cubed hydrogen peroxide was used instead of 20 centimeter cubed of 0.1 mole per decimeter cubed. So we have to do the above two steps again, but this time they have given us different values. So I will explain here. Firstly, we need to calculate the number of moles of hydrogen peroxide. Okay. To calculate the number of moles, we need to write the equation number of moles equals concentration times volume. Okay. Now you can see here the concentration they have given is 0.2. Before it was 0.1, now it's 0.2. So it's 0.2 mole per decimeter cube. So it's in mole per decimeter cube. So you need to convert the volume into decimeter cubed also. So that will be 20 over 1000. So if you calculate this, you'll get 0.2 times 20 multiplied by 1000 divided by 1000. You'll get 0.004 moles of. So we have moles of H2O2 will be 0.004. Now we have the moles of hydrogen peroxide. Now our first step is over, which was calculating the moles of hydrogen peroxide. The second step is to calculate the moles of oxygen. Okay, so number moles of oxygen equals the molar. Now, firstly, we need to calculate the moles of oxygen. We need to determine the molar ratio. So molar ratio, the same equation is used. So the molar ratio is 2 is to 1. Sorry, 2 is to 1. And which is moles of oxygen equals molar ratio. So we have hydrogen peroxide is to oxygen, which is 2 is to 1. So we have the molar ratio for the molar ratio of hydrogen peroxide is 2, and for oxygen it is 1. So all the moles of oxygen will be half of the moles of H2O2. So 0.004 divided by 2, which will give us 0.002 moles of. So moles of oxygen will be 0.002. This is the second step. Now the last and the final step. The last step states, for the last step, now we have to calculate the volume. So we know that volume equals mole times 24. This will be equal to, now the answer is in decimeter cube, so we need to multiply by 24. So we have mole volume equals 0.002. Mole of oxygen is 0.002. This will be multiplied with 24. So you will get the answer as 0.002 times 24. You will get the answer as 0.048 moles of volume of oxygen. So our answer will be 0.048 dm cubed. I hope you're getting it. Now I'll write this answer here to make it so you can understand properly what I'm trying to explain and what I'm trying to write. So our answer will be 0.048 decimeter cubed. I think the last part of this question is here. Yeah, the last part of this fourth question. The student carries out a second experiment to investigate whether another substance, copper 2 oxide, is a better catalyst than manganese 4 oxide. So same experiment is repeated, but this time the catalyst is copper 2 oxide. Describe how the second experiment is carried out. You should clearly state how you will make sure the catalyst is only the variable. Okay, so I've already written the answer for you. So it's here. First, we will measure the rate of decomposition of hydrogen peroxide using same volume and concentration of hydrogen peroxide. Then we will add 1 gram of copper oxide, which is same as the previous experiment, and we will heat at the same temperature as we did in the previous experiment. So these are some key words you need to use: same volume, same concentration, and a constant temperature. Let me just 1 minute right here, 1 minute. So I will just add text. I'll write here my answer, and you can copy this answer to score perfect marks in your exam. Now let me just make it up. It's a 3-mark question. You need to mention 3 points. Okay. The number of mark will determine how many points you need to mention. Now it's the 5th question. This question is about compounds of nitrogen. Describe the Haber's process giving reaction conditions and a chemical equation. Reference to rate is not and real is not required. I have already written this question. So you need to describe it, but you need to include all the reaction conditions, and you need to include a chemical equation. So I have described it here. Hydrogen and nitrogen gases are pumped into the compressor through pipes. The gases are compressed to about 200 atmospheres, which is the pressure inside the compressor. The pressurized gases are pumped into a tank containing layers of catalytic iron beads. These are the catalysts at a temperature of 450 Celsius temperature. Some of the hydrogen and nitrogen react to form ammonia in the following reversible reaction. You need to mention keywords such as reversible or equilibrium. You also mentioned, but I described it. So, and I also given the chemical equation. You know, describe it in your own words so you can score full marks. So I will write here. This is my answer for this question. It's a 5-mark question. All the 5 key points are included, so you can score full marks. Okay, so I'll just make it a bit visible so you can see it properly. Yeah, I think now you can see it properly. You need to include a balanced chemical equation also. Okay, 2 marks is for the chemical equation, and 3 for the, and you need to mention for 3 that this one for the temperature, the pressure, and the catalysts. Okay. 2. Give one use of ammonia. So mainly ammonia is used as one of the main raw material fertilizers in fertilizer production. It's a raw material. So you can write simply this one. It's a raw material in a fertilizer production. Okay. B part. The diagram shows the structure of a hydrazine molecule. Draw the electron arrangement of a hydrazine molecule. So the outer shell electrons only. So electrons are shaded. Okay, so you need to draw a covalent compound. It includes a covalent compound. This type of, you need to learn a dot and cross diagrams. You can learn dot and cross diagrams. So this type of questions will become easy for you. If you practice it, you can score marks more easily in these type of questions. Let me just copy this diagram into my. I can copy it. 1 minute. So this question I'll be placing here. You can see this question. Okay, you can also draw. You can note somewhere in your notebook or in your past paper that you're solving, because some errors, because I cannot copy this diagram into this question. So you can refer to this diagram from the Word document. Part C. 1. Hydrazine is a base. Define the term base. What is a base? Okay. Now they're asking for the definition of the term base. As base is simple. If you know the topic, if you're thorough with the topic acid, bases, and salts, you'll find this definition. Bases are also called alkalis. They're proton acceptors. They ionize in solution, producing H+. They produce H+ ions. Okay, so I'll just copy this statement. Yeah, this is the answer for this statement. So I'll just write here add text, and I will just make sure the answer for this question is basis are proton acceptors. Part 2, complete the chemical equation to show that hydrazine acts as a base when added to water. So if you're writing a chemical equation, you need to balance it also as well. So I'll be showing the chemical equation. So this is the chemical equation. It is balanced. N2H4 plus 2H2O produces 2NH3 plus 2OH. This is the answer for this question. I'll copy it, paste it in the PDF file. This is your answer. This is the complete equation. D part. Nitrogen dioxide is an atmospheric pollutant. State one environmental problem caused by nitrogen dioxide. So one of the main problems caused by nitrogen dioxide is an acid rain. So what is acid rain? Acid rain is a rain that contains dissolved acidic gases such as sulfur dioxide and oxygen and oxides of nitrogen, such as sulfur dioxide. The pH value of normal rain is slightly below 7. The pH value of acid rain is approximately 3.4. So you don't have to mention this description. You just need to write the problem, which is acid rain. It's only for you to explain, only for you, so you can explain, you can understand it properly. So I'll just write here add text, and I'll just copy here, so it will be easy for you to understand the questions. 2. Explain how oxides of nitrogen such as nitrogen dioxide are formed in car engines. So what happens when nitrogen will combine with the nitrogen from your car engines will combine with the oxygen, and nitrogen monoxide is will form. And when this nitrogen monoxide is released from the engines of your vehicles, it combines with the oxygen in the air to form nitrogen dioxide at high temperatures. So you need to mention this point, and you need to mention at high temperatures, otherwise you will lose 1 mark. So this is the answer for this question. Let me highlight it so you can see it properly. Yeah, this is the answer, and I'll write it here. Make sure you follow my answers so you can score perfect marks in your exam. This is my answer. Sixth question. There are 2 more questions to go. One is 6 and 7. So let's start with our 6th question. Iron pyrite FeS2, the chemical formula, is known as the fool's gold because of the shiny yellow solid which is similar in appearance to gold. Iron pyrite is an ionic compound. Gold is a metallic element. Part A. Iron pyrite FeS2 contains positive and negative ions. The positive ions is Fe2 plus. We deduce the formula of the negative ions. So we have 2 elements, which is iron, and we have sulfur. Yeah. We have sulfur. So what we can do here, I'll show you how to do it now. Okay. So there's one thing you need to know about a compound. The valency, the overall charge of a compound, the overall charge of a compound is 0. Of a compound is 0. This is because both positive and negative charges cancel out. Both positive and negative charges cancel out. Okay, so I will not writing here. There's only 1 more question. There's no need to give the description. Just write the answer. So what I'm just for explaining, I'll give the description. So we know that iron has a valency of 2 plus, and S2 we don't know. We can refer to the valency of S2 as X. So we can say X plus 2 equals to 0. Now, to solve this equation, we will send 2 to the other side. So X will be minus 2. So we can say the formula of the negative ion is S2, 2 minus. S2, and the charge is 2 minus. B. A student is provided with a sample of iron pyrite and a sample of gold. So just how could student could distinguish between those 2 substances. So we know gold is a metallic element and iron pyrite is an ionic compound. Now we need to find two different properties of these elements. So how will I find it? Okay, so as gold is a metallic element, it is a good conductor of heat and electricity, and it makes striking sounds, we can say. Hmm. So we know that gold is a, let me just add text. So we can mention here gold is a good conductor of electricity, because all metallic elements are good conductors of heat and electricity. Ionic compounds are also electricity. And second point I can write, gold is sonorous. It makes, like, for example, striking sounds. You can also mention the properties if you are, we can just write and note down the properties of ionic compounds and metallic elements, and you can compare how are they different. Part C states that sulfur dioxide is produced on a large scale by heating iron pyrite strongly in air. The iron pyrite reacts with oxygen in the air, producing iron 3 oxide, Fe2O3, and sulfur dioxide. Construct a chemical equation for the reaction between iron pyrite and oxygen. Remember, 1 mark for chemical equation and 1 mark for balancing it. So I've already balanced it. It's here. This is the equation. Balancing equation seems hard at the first time, but if you practice it, you can balance it. You can balance easily the equations. Now I'll be writing here the chemical equation for you, so then there is no problem. You can refer to these type of questions will come in exam, so you need to know how to balance the equations. Okay, give 1 use of sulfur dioxide in sulfuric acid topic. uh, the uses of sulfur dioxide are given, and one of the uses is as a bleach. It is used as a bleach in the manufacture of wood pulp for paper. So this is the question you can, this is the answer for this question for sulfur dioxide. You can write it here as a bleach in the manufacture of wood pulp for paper. Last question, 7, Part A 1. What is meant by the term hydrocarbon? A simple definition is required, and according to IGCSE, a hydrocarbon is a compound that contains only, remember, you make sure you mention only. If you don't mention only, you will lose that 1 mark and you're gone. So hydrocarbon is a compound that contains only hydrogen and carbon atoms. Make sure you mention only, okay? Because I don't want you to lose marks. That's why. So our answer for this question will be a compound that contains only hydrogen and carbon atoms. Okay, now part 2 is asking for, give the general formula of straight chain alkenes and alkenes. For alkenes, the formula I have already written down. CnH2n plus 2 is the formula for alkenes. You need to make sure you are thorough with the topic of organic chemistry, because this is the most difficult topic, and most students lose marks here for the questions in organic chemistry. And for alkenes, now they're asking, for alkenes, the general formula of straight chain is CnH2n. Okay, I hope you're getting it. Part B, a compound X contains carbon, hydrogen, and oxygen only. X contains 54.54% of carbon by mass, 9.09% of hydrogen by mass, and 36.37% of oxygen by mass. Calculate the empirical formula of compound X. Empirical formula is the formula in the simplest terms. So what you can do is, firstly, you need to find the number of moles for each of the elements. So equation will use moles equals mass over mr. Mr is the molecular mass. Okay, so 1 minute, guys. So here, to calculate, first I'll find moles of carbon. equals, what is the mass of carbon is 54.54, divided by the, what is the MR? It's 12. Basically, MR is the mass number. So you can write moles of carbon is 54.54 over 12. And this will give you, with a decimal place, 1 minute, 54.54 over 12 will get 4.545. 4.545. Now we need to calculate the number of moles of hydrogen. Calculate the number of moles of hydrogen. Moles of hydrogen will be the mass, which is 9.09, and it has a molecular mass of 1. This will give us 9.09. Okay, now then we need to calculate the number of moles of oxygen, which is equal to 36.37, which is the mass, divided by 16 is the molar mass, and this will be equal to 36.37 over 16, which will be equal to 2.27 to the two decimal places. 2.27 two decimal places. Now we have the moles for all the three elements. Now what we can do? Now we need to check. We need to do in its simplest terms. So how we'll do it in its simplest terms? Now if you see these all moles, these are all divisible by 2.27. If you check 4.545 divided by 2.27, the answer is 2. It is divisible. It comes in the 2.27. And if you check 9.09, so 9.09 divided by 2, you will get 4.545. These are all divisible by 2.27. So for this question, we can take the molar ratio. So moles of carbon is to moles of hydrogen is to moles of oxygen. So first one was, for carbon it was 2. For carbon it was 2. For 2.27, for carbon it is, 1 minute, let me just check, 2.27 into 2. For carbon it is 2, and for hydrogen it is, for hydrogen the molar for it is 4, 2 is to 4, and for oxygen it is 1. So we have this is the molar ratio. So now what we can do, we can input these numbers into the equation. Now we have C. For carbon we have how many moles we have for carbon? 2 moles. So we can write 2. For hydrogen we have how many moles? 4. We can write 4. And for oxygen we have only 1 mole, so we write O as it is. Okay, I hope you're getting it. Now for part 2, we have the question. Compound X has a relative molecular mass of 88. Deduce the molecular formula of compound X. To find the molecular formula, what we will do? We will lost it, 1 minute. Molecular formula will be what? How to calculate the molecular formula? Molecular formula will be equal to the empirical. This will be the relative molecular mass divided by the molar mass, or the molecular mass of the compound. Okay, so we have been already given the relative molecular mass, which is 88, and to find the molecular mass of the compound, we'll need to find the mass of C2 plus H4 plus O. So we can do 2 multiplied by 12. Okay, so what you can do, I'll write in brackets 2 multiplied by 12 plus 4 into 1 plus O plus 16 plus 16. So this will give us what? This will give us 44. This will be equal to 88 over 44. Now 88 over 44 will be as 2. So this will be become as 2. Now we need to find the molecular formula. So how we'll do that? So I've already done it here. Therefore C4H8, we'll multiply all the moles for which we have written for this question, C2H4, and multiply 2 with 2, 4 with 2, and this O with 2. So what will be your answer? Well, your answer will be C4, because 2 multiplied by 2 is 4, H8, 4 multiplied by 2 is 8, and O2, because 2 into 1 is 2. So your answer for the molecular formula will be C4H8O2. This is your answer. Part C. An ester has the molecular formula C3H6O2. Name of the ester. Name and give the structural formula of two ester with the molecular formula C3H6O2. Okay, so we have C3H6O2. So what I can do is C3H6O2. To find the structural formula of these two esters, I mean, you can also name it. So we'll get the first ester will be CH3, COO, and CH3. The name of this after I'll tell. And the second ester will be, when the water molecule is removed, we'll have the formula for this one, HCOO, C2H5. You need to be thorough with the topics for condensation polymers and addition polymers so you can easily solve these type of questions. Now, if you check this question, this one is methyl ethanoate. Okay, this one is methyl ethanoate. Met is 1, eth is 2. So firstly, you can see here we have one carbon atom, and this in the second portion we have two carbon atoms, COOCH3. So we can say here answer is methyl ethanoate. And for this ester, we have to name it. So firstly, we have only one carbon atom. So this one will be ethyl methanoate. They are the esters you have received. Now, name the ester produced from the reaction of propanoic acid and methanol. Okay, if you check the name of the esters, the alcohol part comes first, which ends with ethyl, and the acidic part will come after it, which will end it as all. So we can write here methyl propanoate. So I'll write here my answer as methyl propanoate. Okay, now part E, last part of this question. A polyester is represented by the structure shown. What type of polymerization is used for the production of polyesters? Whenever these type of diagrams come in exam, it means the polymerization is condensation. So we can write here condensation. There are two types of addition and condensation, but if these type of diagrams come, this means a type of condensation, polymerization. Now, 2 is which simple molecule is removed when polyester is formed. So it is always the water. You can see now whenever the alcohol and acid reacts, so the H from the alcohol and OH from the acid is removed. So that is the water part is removed. Okay. Now complete the diagram to show the structure of the monomers used to produce the polyester. Show all the atoms and the bonds. So I have a picture for this. Just give me 1 minute. I'll just show you the picture. Let me just. Actually, I was also confused in this question. Then one of my friends told me about that. Let me just show you the picture. 1 minute. This is the picture. So he has. Actually, he's a teacher now. So I'll take a print screen of this. Can't take print screen. So you can call, so this image you can just, okay. So I'll just upload this picture in the PDF file, so you can refer to this and you can write this answer in your. This is your answer for the last E part. All the answers are mentioned, and you can see here. Let me stick it up. Okay, this is the answer. I hope you liked the video. Please don't forget to subscribe, like, share, comment, and stay tuned for more videos. Thank you.